Organic inhibitors versus inorganic inhibitors, pros and cons. Inhibitors play a vital role in controlling corrosion in various industries. The objective of using inhibitors in metal systems is to reduce the rate of the metal's corrosion or to prevent it. Altoge. Her. Two commonly used types of inhibitors are organic and inorganic inhibitors. Both types have various pros and cons, and choosing the right inhibitor depends on several factors. Organic inhibitors. Organic inhibitors are chemical compounds consisting of carbon, hydrogen, oxygen, and nitrogen. These inhibitors are extracted from plants or synthetically produced in a laboratory, and they are used in various metal systems to control corrosion. The primary advantage of organic inhibitors is their environmentally friendly nature and their ability to biodegrade. They represent a better alternative to inorganic inhibitors, especially when environmental safety is a concern. Pros. Environmental safety. Organic inhibitors are biodegradable, and they do not accumulate in the environment. Hence, they pose no threat to the ecosystem, making them an environmentally safe option. Cost-effective. The cost of organic inhibitors is not as high as that of inorganic inhibitors. This benefit reduces the cost of operations, making them a cost-effective corrosion control option. High performance. Organic inhibitors are effective in controlling corrosion rates. They inhibit the anodic or cathodic reactions, which lead to metal degradation, preventing the formation of corrosion. Ion products. Multifunctional. Organic inhibitors can be used in several metal systems, unlike inorganic inhibitors, which are limited to specific metal systems. Inhibition efficiency. In several instances, organic inhibitors can achieve excellent inhibition efficiency, which is superior to inorganic inhibitors. Cons. Short-term effectiveness. The effectiveness of organic inhibitors is short-term compared to their inorganic counterparts. This puts more pressure on the maintenance teams to apply them frequently. Increased risk of contamination. Organic inhibitors can be easily contaminated by microorganisms, leading to their degradation, which affects their effectiveness negatively. Sensitivity to environmental parameters. Organic inhibitors require specific environmental conditions to work effectively. Their ability to control corrosion is highly dependent on temperature, pH, and other environmental factors. Required pretesting. Before using organic inhibitors, it is necessary to carry out pretesting to determine their suitability for different metals. Inorganic inhibitors. Inorganic inhibitors, also known as inorganic salts, are chemical compounds containing metallic or nonmetallic ions. These inhibitors are used in many industries, including oil and gas, manufacturing, and construction. The primary advantage of inorganic inhibitors is their ability to provide long-term corrosion protection and stability under a range of environmental conditions. Pros. Long-term effectiveness. Inorganic inhibitors offer long-term protection and stability against corrosion, which reduces maintenance needs in metal systems. High inhibition efficiency. Inorganic inhibitors provide high efficiency in preventing or reducing metal corrosion rates. Versatility. Inorganic inhibitors have different types of metallic or nonmetallic ions, which enable them to be effectively used in different types of metal systems. Cons. Environmental safety. Inorganic inhibitors are not biodegradable, which makes them potentially harmful to the environment. They accumulate in water bodies and soil, leading to pollution and environment. Mental degradation. Limited use. Inorganic inhibitors are limited to specific metal systems, and therefore, they may not be appropriate for use in other metal systems. High costs. Inorganic inhibitors are more expensive than organic inhibitors, which makes them less financially accessible, especially for small businesses. Toxicity. Some inorganic inhibitors can be hazardous to human health and the environment. This aspect requires careful handling, storage, and disposal to safeguard against adverse effects. Choosing between organic and inorganic inhibitors. The choice of the best inhibitors for corrosion control depends on various factors that include the operating environment, metal system, and application. The cost, efficiency, and environmental consequences. RNS also play a significant factor. For instance, inorganic inhibitors may be the ideal option for industries such as oil and gas, where they provide long-term stability under harsh conditions. On the other hand, organic inhibitors are the best option for industries where environmental safety is a concern. It is worth noting that some industries have begun to shift towards using more sustainable and eco-friendly corrosion inhibitors, often derived from agricultural waste or other renewable sources. Say inhibitors offer an innovative and environmentally responsible solution to corrosion control. Additionally, some researchers have explored the use of nanotechnology in corrosion inhibition, which allows for the development of more efficient and targeted inhibitors. This technology has the potential to revolutionize corrosion control and improve the performance of both organic and inorganic inhibitors. In summary, inhibitors play a crucial role in preventing and reducing corrosion in metal systems across various industries. The choice between organic and inorganic inhibitors depends on numerous factors, including environmental concerns, cost-effectiveness, and corrosion control efficiency. Industries must evaluate each inhibitor's potential advantages and disadvantages to identify the best corrosion inhibitor for their metal system and application. The development of sustainable and innovative inhibitors, such as those derived from agricultural waste and nanotechnology, may offer exciting solutions to new challenges in corrosion control. Corrosion is a significant challenge in the metal industry, and its management is essential for avoiding significant losses resulting from material destruction and downtime. Inhibitors remain a crucial option for corrosion control due to their effectiveness in reducing or preventing corrosion rates in metal systems. However, the choice of inhibitor to be used is critical, as it determines the effectiveness of corrosion management and the cost of operations. Organic inhibitors have several advantages, such as their environmental safety, cost-effectiveness, and high inhibition efficiency. Being biodegradable makes them an ideal option for industries that prioritize environmental safety. Their cost-effectiveness also allows for their broad use, reducing the overall cost of operations concerning corrosion management. Moreover, their high inhibition efficiency makes them effective in reducing corrosion rates. However, the short-term effectiveness of organic inhibitors, their sensitivity to environmental parameters, and their vulnerability to contamination limit their use in some industries. Inorganic inhibitors are preferred for their long-term effectiveness and stability under harsh environmental conditions. Their effectiveness in preventing or reducing corrosion rates is also high, making them ideal for industries with critical metal systems. However, their cost, environmental safety, and limited use limit their use in some applications. Being non-biodegradable makes them potentially harmful to the environment, while their high cost puts them out of reach of small businesses. Industries must consider the operating environment, metal system, application, cost, and environmental concerns when selecting corrosion inhibitors. Moreover, the evaluation of each inhibitor's potential advantages and disadvantages is essential for making informed decisions about the most appropriate inhibitor. In addition to organic and inorganic inhibitors, there is a growing interest in the development of sustainable and innovative inhibitors that are eco-friendly and highly efficient. This includes inhibitors derived from agricultural waste and those using nanotechnology, which target specific metal systems and reduce the overall cost of operations.